So they can hand you a linear equation by a word problem. There's a couple ways they can do it. Here, they actually give us 2 points. Sometimes they'll say, it starts here and the rate of change was this. Starts here, y-intercept, rate of change, slope, okay? But sometimes they'll give you 2 sets of things. It says a race car driver was performing an engine stress test and he drives at a constant speed around a test track. After 20 minutes, he drove 60 miles. After 30 minutes, he drove 90 miles, okay? That is my XY. So they gave me X 20, Y 60, X 30, Y 90. They want me to give a function that models this. My function is going to be y equals mx plus b, okay? To find my m, I'm going to do exactly what I would do before. I'm going to subtract my y's, subtract my x's. All right, I get 30 over 10, which is just 3, and this is my miles per minute. All right, 3, that's my slope. They want a function. Well, y equals mx plus b is fine. I can use this one. Y equals mx plus b. My b here is going to be 0. 60 equals 60 plus b. By the way, your y-intercept in a word problem is usually your starting amount. How fast would he have started in a car? 0, right? So it makes sense that my y-intercept here would be 0. This is a logical starting point when you're in a car. Most people start at 0 miles per minute in a car, right? Now that I know my slope and my y-intercept, I can plug it in. Y equals mx plus b. So y equals 3x. All right, they used it with time, by the way. So they went, they did a function format. So they did this, or they said dt equals 3t. But this is fine. This represents the same thing. Y equals mx plus b. And so they can hand you a word problem and they can give you slope, y-intercept, but it's going to be hidden in the words. Or they can give you xy. And all they've done is given you 2 sets of points. They've actually asked the same question we've been looking at. Find the equation between these 2 points, but they hid the points in the word problem, okay? An xy and an xy. And so solving it is exactly the same. Solve for your slope, use your y equals mx plus b. Very often they will use word shading for word problems because they're trying to say, I could mix and match and do this or that. In this example, they said the athletic department is attempting to raise $600 by selling t-shirts and sweatshirts. They're charging $4 per t-shirt, $10 per sweatshirt. And so they want us to model it. And you can see that they set this up. $4 per t-shirt plus $10 for sweatshirt is going to be at least $600. All right, so they have t-shirts and sweatshirts. So instead of an X and a Y, they have a t-shirt here, a sweatshirt here. All right, and they did the same thing. They found their intercepts. They took 600 divided by 4, and they got their x-intercept. 600 divided by 10, and they got their y-intercept. And then they said, I want at least $600. So then they shaded everything above it. That means any mix and match of anything on the line or above it will give them their $600 or more. So if I were to say, okay, I'm going to sell 100 t-shirts and 40 sweatshirts, that is going to make me at least $600, if not more. And it actually will be more. And so they use this for word problems as well to say, what do I need to sell to make it within what I want to make? And any mix and match of anything in my shaded area will make the $600 that they're trying to make. All right. So they've done the same exact thing. They've set up a simple equation, but you will notice on word problems, they didn't use like 1, 2, 3, 4, 5. They set up their divisions a little bit bigger than that to fit what they needed it to fit. All right. So you'll notice that we have every 10 here instead of every 1, obviously. So you may have to adjust your graph lines to fit a larger set of numbers. So this is actually pulling from some information that we talked about with the linear equations, okay? And a term from basically geometry, hopefully you remember. Perpendicular bisector. What happens if something bisects something? It cuts it in half. So if I am talking about a line segment, where would I cut it in half? At what specific point? One that we just found. The midpoint, okay? So they're telling us, we want you to go through the midpoint. And we want you to go through perpendicular, all right? So two things here. One, we need to know what the midpoint is. And they actually want us to use the example we just did. So we found the midpoint of example 2 here. Not the ones y'all just did, but the example 2 that we just did. -1, 13/2 was my midpoint, okay? So I know that that is the point that they want the line to go through, all right? So if you think about a coordinate plane here, we're going to do one really quickly so you can see it. Shrink it down a little bit. We have the line segment that starts at -3, 4, all right? So -3, +4 is right here. And then we have it ending at 1, 9, okay? So 1, 9 is way up here. This is my line segment. All right, so if I were to just look at this line segment, they want me to have another line go through this at a specific point. Well, the specific point that they wanted to go through is -1, 13/2, which is right at 6.5, right? So we figured out that the midpoint was right about here, okay? So we know the line that we're talking about is going to go through that point, all right? We also know that it's going to be perpendicular to this line. What do we need to know if we need to get an equation of a line that's perpendicular to a line? What do we need to know about that line? What do we know about perpendicular lines?
You know their slope.
We know their slopes are what specifically?
The negative reciprocal.
Right, so I need a point, which I have, and I need a slope to be able to figure out the equation. But I don't know the slope. And in fact, I don't know the slope of the other line, but they have given me 2 points of the other line, right? So I can definitely figure out the slope of this line segment using these 2 points, right? Do you actually have to use these 2 points to figure it out if I have it? You can just count, really. That's what you're doing. Change in y over change in x, right? So how far up am I going? Which is really what you're doing, by the way, when you do the slope formula, okay? Is this going to be a positive or a negative slope? Look at it. Positive or negative slope? It's going to be a positive slope, right? My y's go from 4 to 9, right? 4 to 9. So if I were to do counting, which is basic subtraction, right? If I were to count from 4 to 9, what would I get? How many up would I go? I would go 5, right? Which is the same thing if I subtracted my y's, by the way. 9 minus 4, okay? Slope formula. And then I am walking from -3 to +1, right? How much did I walk there? 4, okay? Which, by the way, is what happens when I do 1 minus a -3, right? So that is the slope formula. So I do know the slope of this line. So I have a point that I'm going to go through, and I know the slope of the line that I'm going to go through, right? That's not the slope I need to use, though. What specifically did they say about this line that I'm going to use? It's what? It's perpendicular. So what do I need to do to this slope? I need to flip it, so it's going to be 4 over 5. And I need to change the sign. It was positive. I need to make it negative, right? So now I know the slope that I'm going to use. And so I'm going to take this slope right here, and I'm going to take these numbers right here, and I'm going to come up with the slope-intercept form. It's also important that I remember what slope-intercept form is. Y equals mx plus b, all right? So the only piece I'm missing actually to fill this in is the b, and I'm going to use those 2 points to figure that out. So my y value is what? What's my y value of my point? 13/2. What is my x value of my point? -1. And so now I'm going to solve it. -4 and 4/5 and -1 just give me a positive 4/5. 4/5 plus b equals 13/2, right? I'm going to run out of room, so we'll scoot all this up. He is not scooting up well. All right. Subtract my 4/5. Subtract my 4/5. What do I need when I'm subtracting fractions? Common denominator. What is my common denominator between 5 and 2? 10. So I need to multiply this by 5, and I need to multiply this by 2, right? 5 times 13 is 65. 5 times 12 is 60, right? And then we're minusing 2 and 4 give me the 8 over 10, right? So 65 minus 8, where am I? 57, right? Over 10. That is my B. That's what I solved for, right? I know there's crazy fractions, but basically you're just solving for B. You did it on your quiz for me, okay? Am I done? They want the slope-intercept form of the equation. Am I done? No. I have my M and I have my B, but what do I need to do to those two? I need to plug them in. My slope-intercept form of this equation is going to be y equals, what was my M? Negative 4 over 5. X plus what was my B? A hideous 57 over 10, right? That is going to be the line that goes perpendicular through this guy. And so if you were to look at this line, and I were to actually graph this line, it would go at a right angle actually through this point right here. That would go through the midpoint and look like that. And you'll see it actually does cross at about 5 7/10 is where it would cross. So a little past 5 there.